Welcome back to the deep dive where we slice through the noise to get you right to the point. Today we're peeling back the layers on a pretty major shift in enterprise AI. We're talking about how these big language models are breaking out of their silos, and they're doing that by integrating with something called the Model Context Protocol, or MCP. Our source material for this is basically a technical demo, an overview of this exact integration process. So if you've been wondering how AI scales from, just a niche tool into a platform that's powerful, secure, and everywhere, this is for you.
Exactly. And our mission today is really to get past the marketing hype and into the mechanics. How does integrating with this MCP thing actually change how a system behaves? We want to understand what makes it more efficient, scalable, and maybe most importantly, secure. And the sources lay out five core enhancements that make this happen, things like dynamic communication, tool autonomy, and robust security.
Okay, so let's unpack this. The term Model Context Protocol, it probably raises a question for you, our listener. I mean, what is it actually standardizing? Because without knowing that, all these benefits, they just sound like, well, promises.
That's the perfect place to start. If you think of AI models as the engines, the MCP is, well, it's like the operating system, the networking layer, and the data standard all rolled into one. It standardizes three key things. First, the ABIs, so different models can actually talk to each other.
Right.
Second, how the system memory is tracked, what we call state management. And third, metadata exchange. So when one model sends data to another, they both understand what it is, its security level, and, its current status.
So it's the universal translator, the thing that lets everything else happen. And the first benefit we see from this is dynamic interaction. The source material calls it dynamic, real-time AI communication. When we say real-time, what are we actually talking about here? Why is that such a big deal for the user?
Well, we're moving past that old request-response model, where you type a query, hit send, and then you wait. Dynamic communication means the AI isn't just sitting there waiting. It's adaptive. It's anticipatory.
Can you give me a tangible example?
Sure. Imagine you're drafting, say, a complex legal document with an AI. The second you type a keyword, like international trade law, the AI isn't waiting for you to finish. It's already prefetching relevant clauses, adjusting its whole response structure on the fly.
So the lag, the perceived latency just vanishes.
And it vanishes. The interaction feels less like you're using software and more like you're having a high-speed back and forth with an expert. It's fluid.
That makes sense. But speed is one thing. If the AI is reacting that quickly, doesn't that create a risk of it just spitting out generic or even wrong answers that are totally out of context?
And that's where the real power of the MCP standardization comes in. It leads us straight to the next point, which is step 4. AI maintains context for smarter, relevant responses. Speed is great, but context is what makes it a partner, not just a tool.
Okay, so how does it maintain that context? What's the mechanism?
The MCP creates what are called persistent session tokens. Think of them as a continuous memory thread. These tokens are linked to a knowledge graph that's constantly updating. It's tracking your current conversation, sure, but it's also referencing all your past interactions, your preferences, the whole history.
So it's not like a simple chatbot that forgets who you are after 5 minutes.
Miles beyond that. This isn't stateless. You don't have to feed it the whole history of your conversation with every single query. The MCP handles all of that heavy lifting.
I see. So if I ask it to follow up on an analysis I started last week.
It pulls up that entire history instantly. The responses are smarter, they're personalized, because the AI isn't wasting time relearning who you are and what you're doing.
So we're moving from a transactional AI to a collaborative AI. The real-time speed plus that persistent memory. That's what creates an experience that actually feels intelligent. Okay, so that handles the speed and relevance problems. But the next set of steps, this is where it gets, for me, really interesting. We're moving beyond just being responsive and into, well, self-sufficiency. Let's talk about step 3. AI autonomously discovers and integrates new tools.
This is the feature that really future-proofs the system. I mean, for years, adding a new service or API to an enterprise system was this huge, manual, expensive process.
Right, months of development, testing. It was always a headache.
It was a massive bottleneck, but an MCP-integrated AI can remove it.
How does that discovery process even work? Is it just scanning a list of approved APIs or something?
It's a bit more sophisticated than that. It's doing what's called capability mapping. The AI identifies a gap in its own toolset. It might realize, hey, I need real-time stock data or a specific financial model I don't have. It then discovers an external service that fits the bill, and this is the crucial part, meets the MCP's security and integration standards.
So the AI is literally expanding its own toolbox as needed. But wait a second. If it's autonomously integrating external services, tools that my own engineers haven't vetted, doesn't that open up a huge new security risk?
That is the absolute critical challenge here, and it's why the MCP is so essential. The protocol forces every tool, internal or external, to operate inside a secure wrapper. The AI doesn't just plug in a raw API, it automatically generates a wrapper that enforces the MCP's rules on security and resource use.
For a wrapper, okay.
Yeah, and on top of that, the MCP manages version control. So if an external tool becomes unstable or gets a bad update, the protocol can isolate it immediately. It prevents one bad tool from bringing down the entire system.
It's like a managed automated marketplace for its own abilities.
Right.
That's revolutionary.
It is. It keeps the system on the cutting edge without constant manual intervention.
And that idea flows right into step 5, which is about integrating new services without workflow disruptions.
Right. I mean, think about the real-world problem of deploying anything new in a live environment. It always means downtime or maintenance windows, or at least some system lag.
Of course.
The MCP gets around this by enforcing seamless integration.
And how is it non-intrusive? Are we talking about things like containerization or blue-green deployments?
Exactly, those kinds of principles. The MCP uses things like atomic deployment. It might run a new service in parallel with the old one secretly until it's fully validated. Then, when the AI integrates that new tool, the protocol handles the orchestration. The switchover is, for all practical purposes, instantaneous.
So for you, the user, the bottom line is zero downtime.
Zero downtime. You just get new functionality. The system's performance and productivity are maintained, and the complexity is completely hidden from you.
Okay, so to sum up where we are, we've got real-time, context-aware communication and a system that's continuously evolving itself without ever needing to stop. But all of this power has to be built on an ironclad foundation of trust, which brings us to security. If the system is this autonomous, adding its own tools, managing real-time data, the whole thing rests on its security standards. So let's look at step 6. Standardized protocols ensure robust security. What are we actually talking about here? This has to be more than just a standard firewall.
Oh, absolutely. Security within the MCP is built from the ground up on zero trust principles.
Zero trust. So verify everything, always.
Always. Every single interaction, every data transfer, every tool has to prove its identity of authority every time. It doesn't matter where it is or if it was trusted 5 seconds ago. We're talking about enforced standards like TLS 1.3 for all communications, so everything is encrypted. And crucially, the protocol can tokenize or mask sensitive data before it even gets to certain models.
Which is huge for compliance, things like IPay or SOC2.
Exactly. The system can be configured to meet those strict regulatory frameworks.
So security isn't some wall around the system. It's the language every component has to speak internally.
That's a perfect way of putting it. Because the MCP defines the rules for all data movement, it can demand encryption and access control at the protocol layer itself. This completely sidesteps that risk we talked about, the AI accidentally opening up a vulnerability by integrating an unvetted tool. The MCP is the gatekeeper.
Right, so connecting it back to autonomous tools, the AI doesn't just integrate a tool because it's useful. It can only integrate it if the MCP certifies that it meets all those security and compliance standards first.
That's it. That foundational trust is the silent enabler for everything else. Without it, you would never allow autonomous discovery. The stability these protocols provide lets the system be both incredibly aggressive in its self-improvement and, at the same time, fundamentally cautious.
This has been a really insightful look into the actual mechanics of this. Let's just zoom out for a second and look at the cumulative effect of what we've unpacked. We've got an AI that operates in real time with full context. It can autonomously find and integrate new tools without any disruption. And this whole thing is built on a foundation of standardized, zero-trust security.
And if we tie this all together for you, the listener, what it really means is that this architecture solves the biggest challenges facing AI adoption right now.
Right.
Efficiency, scalability, and security. It moves AI from being, a collection of powerful but separate tools into a single, continuously self-improving utility that just works reliably and safely across an entire organization.
So what does this all mean for the future of how we design systems? I mean, if you have an AI system built on this protocol that's constantly improving itself, autonomously deciding what tools it needs, and maintaining deep context over maybe years of interaction. What's the theoretical limit? When that self-improvement loop is designed to be continuous, where does that growth and capability ultimately plateau? Something to think about. Thank you for joining us for this deep dive into AI and the model context protocol. We'll catch you next time.